Good evening, students. Again, in front of you, it is very important topic today. How the performance of an engine can be calculated. What we are using all vehicles, two-wheeler, four-wheeler, trucks, bus, all these. The performance calculations, the performance characteristics. Simply, we can call it performance of an internal combustion engine, petrol or diesels, or whatever the CNG, petrol, diesel, aerospace, aerospace, wherever it may be. Where the pistons will reciprocate, definitely cylinder content means how we can calculate the performance of an engine and what its objective and what the parameters it required to assess the performance or efficiency of an engine. You'll see one by one. So now, the performance of an IC engines are simply call it as a testing of an engines. Why the testing is required? Why the testing is required means it analyzes the graphic presentations or analytical presentations of the minimum characteristics or parameters of an engines. Okay, so here to check the validity of the design data used by the manufacturers. To check the validity of the design data used by mechanical engineers at industry is right or wrong. Some advertisement is holding 80 km per hour, 70 km per liter. Can you believe it? No. To check this, being a mechanical engineer, to analyze the performance of a petrol and diesel engine, its working condition. So, to check the validity of design data used by the manufacturers, and whereas second, to know the performance characteristics. What the characteristics means? All powers: input power, output power, loss of power, efficiency. The ratio of these two. One is input power, another one is output power, next one is loss of power, next is efficiency, the ratio, and finally thermal efficiency. How much the fuel is consumed, what the efficiency of an engine, and say 70 km per liter of petrol, or you believe it? Suppose 100 cc bike, 100 cc, 80 km per liter, we can't believe it. The people company say, to check that validity of the design data used by engineer, the testing of an engine is essential. Each and every makers at all industries, every maker in almost Tata Motors, Mercedes-Benz, BMW, Audi, Ashok Leyland, or wherever the before going to the engines to the assembly sections, after testing by the testing engineers, then only it will give the approval for testing. So what are the first parameters? Now, number one. So first one is mean effective pressures. Mean effective pressure. Mean means what? Average. There are 3 to 4, 5 cylinders. Every cylinder, how much the pressure is generating, we don't know that. To calculate that mean effective pressure, how means we need one indicator diagram, its name, ID. Generally, in mechanical engineering, ID, indicator diagram. With the indicator diagram, it explains about the graphic presentations. Graphic presentation in the form of PV diagram, pressure versus volume, in the form of a graph, here RPM versus fuel consumptions, BP versus mechanical efficiency, IP versus fuel consumptions. These are all parameters. You will make it a graph. In that graph, the first parameter is indicated mean effective pressure. It is the average pressure available at the engine cylinders without ignition. Just only the pressure will be there, minimum pressure. That pressure is called indicated mean effective pressure. It is measured by indicator diagram. So here to calculate this, the notations where PM, P suffix M, PM is equal to A into S divided by L. What is A, S and L? These are the parameters of indicator diagrams. In PV diagrams, pressure versus volume, RPM versus fuel consumptions, mechanical efficiency versus brake thermal efficiency. So these are all parameters. So by using these parameters and their limitations, where the small a, area of indicator diagram in mm square, and S is spring scale reading, and L is length of the spring ID. Indicator diagram. By using this formula, we can get it here A into S by L. So we can get it bar per mm or kilonewton per meter square per mm or Pascal per mm also. Depends upon this ES unit. Because S is spin scale reading, A is area of indicator diagram, L is spin level. So now indicated power. What the indicated power is? So indicated power is simply where the power is induced inside the engine cylinders. After complete combustion of an air and fuel mixture in the cylinder, whatever the power is released individually are called whole average. That is called indicated power. It is represented by IP. How can calculate mathematically equation? So IP is equal to plan PM LAN divided by 60 into C. where PM is indicated mean effective pressure in bar per mm or kilonewton per meter square per mm, and where L is stroke length distance between TDC to BDC, and where A is area of cylinder or diameter or pistons. Diameter of the cylinder or totally area of the cylinder. How can calculate pi by 4 DC square? Simple. Where A equal to pi by 4 DC square. What is DC? Diameter of the cylinder in meter. All dimensions are in meter only. And where the N is number of working strokes. Number of working strokes. It means how many working strokes? RPM. Unit is RPM. So these are notations where DC diameter of cylinder mm and N is number of working strokes. And in case of this all 4-stroke engine, N by 2. Why? Because as the number of cylinders where it is the 4 cylinder, 4 stroke. If the 4 times it is rotating, means how many times power will develop? 2 times. Therefore, the revolution by 2, half of RPM. It's called 4-stroke engine. 4-stroke engine only, wherever the given RPM, you can divide by 2. And where the C is number of cylinders. Simple single, all motorcycle only 1 cylinder. In twin cylinder, nano car, Maruti 800 3 cylinder, other cars are 4 cylinder, all trucks and buses are 6 cylinders. C becomes 1, 2, 3, 4, 5, 6 up to 12. C is multiple factor for number of cylinders. If C is not there, it means simply meaning is for 1 cylinder parameters. So where the power induced inside the engine cylinder by combustion of complete fuel mixture, it is called indicated power. So it can be calculated by the mathematical applications. Expression is called formula. Next we go for brake power, output power. So it is called input power. But we don't say it is input now. Input power. How much the power is input to the engines in the form of an air plus petrol. Output power, the brake power. Input power is always more than the output power. How can calculate? Again, we have the instruments we required. What the instrument is? So generally a dynamometer. Dynamometer. It may be brake dynamometer, or rope brake dynamometer, or hydraulic dynamometer, or prone brake dynamometer, or electronic measurement nowadays, and even pneumatic operating dynamometers also. So 4 to 5 different types of dynamometers are there. But most commonly used by engineers and industry, rope brake dynamometer or simply dynamometer. Dynamometer is a mechanical device which is used for measuring a fan brake power. Where it is available on the engine crankshaft. If the shaft is rotating continuously, we hold it. How much force is required? How can calculate? We can hold it. So that power, brake power. Brake power by using dynamometer only. These are called all the parameters where dynamometer. Remember this. Not dynamo, dynamometer. So, dynamometer is a mechanical device which is used for measuring of an brake power available at the engine crankshaft. If this BP is equal to 2 pi nt divided by 60. 2 pi radians. Radians. So, T, torque. Torque is what? Load into perpendicular distance. How much load is exerting at what distance? Load and its perpendicular distance is called torque. Torque is equal to load into perpendicular distance. Again, a prone brake dynamometer. Divided by 60 constant factor, 60. Because 2 pi and T, N is RPM, revolution per minute. So then 1000 is multiply factor to get conversion of watts to kilowatts. Watts to kilowatts. If you are not taking this 1000 as a dividing factor, denominator factor, you will get watts. If you divide by 1000, it becomes kilowatts. So this is one. And another method also, we can calculate this BP by using brake dynamometer. W minus S net load, where W is dead load. S is spring balance reading. Not this small s. Small s is different, this s is different. You don't compare capital S with the small s. Notations there. Here, spring balance reading and W minus S combined together, you can call a net load on the brake dynamometer, and pi and D is circumference. Pi and D, where D is diameter of the brake wheel or brake drum. Capital D is diameter of the brake drum, not small d. Different here. N is speed, RPM. So 60 to 1000 again kilowatts. Again, one more formula is C. This is called BP is equal to W minus S pi capital D small dr into N divided by 60 into 1000. What is dr is new? This is the diameter of the rope. It means rope brake dynamometer. It is simply brake dynamometer. It is rope brake dynamometer. Here a rope diameter is not considered to the account calculating of this BP. But here in case C, here rope dynamometer consideration, we are calculating the BP of an engine in kilowatts. RPM is same here. No divided by 2 because this is available at the engine crankshaft. The power is available at the engine crankshaft is called a brake power, called output power. So next is frictional power, it is the loss of powers. What is the difference? What is the input and output? Difference, higher minus lower. Input power is more than the output power. IP is always greater than BP. So IP is more, BP less related to subtract it, just you get loss of power, a loss of due to cooling, loss of due to negligence of maintenance, loss of due to cooling of an overheating of an engine, a loss of due to friction of an idling, a lubrication system. There are so many parameters. Loss of power, the frictional power is equal to difference of IP minus BP. How can calculate efficiency? So it mechanical efficiency, simply efficiency mod bit, output divided by input. Input is more. Output divided by input, because input power is more, but with the loss of power. So it means actually how much the power is input and what we want to achieve. How much we want to achieve and what we want to receive. So that is called BP by IP. That ratio, the multiplied by efficiency is in percentage. It is a eta m mechanical efficiency BP divided by IP into multiplied factor as a 100. Okay, effort of an engine are simply efficiency, output by input. Output is brake power, input is indicated power. So now indicated thermal efficiency, there are so many thermal efficiency, indicated thermal efficiency, overall thermal efficiency, relative efficiency, brake thermal efficiency, volumetric efficiency, all efficiency. What it meaning? So indicated thermal efficiency, how we can calculate? Here for development of an one IP, 1 kilowatt power, how much the fuel is supplied? That is heat supplied. How much heat is supplied? Heat is supplied in terms of mass of fuel consumed and its calorific value. Mass of fuel consumption and calorific value. When 60, what the IP is kilowatt and this is MF is in kg per hour. So this is 60 into 60. Multiple factor, it is in efficiency. If you are taking IP as a consideration, that become indicated thermal efficiency. It means the ratio of an one IP produced to how much the fuel is supplied by that fuel. Heat is supplied by the fuel. And where the brake thermal efficiency, just replace by IP to BP. BP into 60 into 60 divided by MF into CV multiplied by 100. So simple, these are the essential parameters, 5 parameters, more than 5 to 6 steps. So to assess the performance of an engine, after evaluated by the testing engineer at industries, the finally after quality department will come out from the testing centers. Okay, now you'll see in the coming class how the balance should be done in this sheet and it will be the next class. Thank you. Thank you.